This liquid gold came from a pile of circuit boards. And these days, there could be more gold in a landfill than in a mine. But extracting it is an expensive and polluting process, often carried out at toxic dumps. Now, a New Zealand startup has found a cleaner and safer way to do that. And its secret ingredient comes from nature, microscopic organisms that evolved to absorb precious metals. But can this complex process reinvent how we deal with the world's fastest growing waste stream? We visited the test plant to find out. Mint innovation begins with the circuit boards that are inside nearly every electronic device.
So this is how the electronics, the circuit boards, this is how we receive them, cut up, shredded into pieces.
The company says it sources all raw material from a local recycler.
Exporting waste is an absolutely abhorrent thing for the human race to be doing.
The company's founders think that if it's easier to get valuable metals from e-waste, countries will choose to deal with it locally.
A lot of the gold's wrapped up in these chips.
The first step is to grind the circuit boards into a sand-like consistency. Workers shovel this sand into a reactor, which mixes it with inexpensive chemicals.
Those acids and oxidants are pretty commonly available industrial chemicals.
Next, machines pump the mixture into a filter press to separate the liquids from the solids. This blue fluid contains a high concentration of copper, tin, and other less valuable metals. Mint uses electricity to pull out the copper.
We simply put that through a series of plates, pass it over that have electric current flowing through them, and that plates out the copper from solution.
The metals that pay the bills are the gold, the palladium, the copper and the tin because they're most abundant and most valuable.
But at this step in Mint's process, palladium and gold are still stuck in the solids. They're harder to dissolve and require another chemical bath.
For the precious metals, you need something with a little bit more oomph, so that's why we break it into two stages.
The next step in Mint's process makes it one of a kind, and it requires the help of nature.
We're the first people to use microorganisms to selectively concentrate precious metals. We're kind of inventing the whole technology along the way.
Mint's team identified these tiny helpers in 2017 through a series of research trips to places like abandoned mines or fields with rusty equipment.
Given enough pressure and time, microbes seem to find a way to thrive in any environment.
They collected species of bacteria and fungi that evolved to bond with specific metals.
Our microorganisms recover gold. They also recover palladium.
These are not pathogens by any stretch of the imagination. So would I drink a vial of them? Probably not, but I wouldn't drink a vial of a lot of things. So.
Over several hours, the microbes will gain weight as they absorb precious metal ions.
And we've now got a concentrated microbial paste that contains a good portion of precious metal.
When the paste dries out, the gold nanoparticles in it start to appear purple.
Gold has this funny property that when it is in small nanoparticles, as well, gold and colour have this hue of blues to reds.
The mixture is ready for the last step.
So this is where the final bit of magic happens, where we burn off the microbial part, just leaving the metal part behind that they've captured.
Our product is a gold-rich ash. That goes to a refiner who is the one who turns it into your 99.99% gold.
It takes 1 week to extract 150 grams of gold from 1 ton of circuit boards. The founders carry around this solid gold coin to show what that looks like.
Is it pure gold?
That's pure gold.
Super heavy.
It seems like a lot of work for a small payoff. Is it really worth the trouble? Mint's founders say yes, because it's getting harder to mine precious metals from the earth.
The big gold mines are recovering literally grams, 3, 4, 5 grams of gold from a ton of rock. 81% of gold that's identified today is already above the ground.
And as gold mines are depleted, the amount of e-waste generated globally has increased steadily over the past decades. If those trends continue, by 2050, we'll have to deal with 110 million metric tons of e-waste every year. That's like every person in the world throwing away a countertop microwave. Up to a fifth of all e-waste moves across borders, likely ending up in developing countries where workers process it by hand at illegal dump sites. Activist Jim Puckett has spent over 25 years tracking how e-waste ends up in these toxic environments.
The entire life cycle of electronics, unfortunately, disproportionately burdens the global south with the real environmental harm and pollution.
Thousands of people worldwide make a living extracting copper from e-waste, primarily by burning it. Inhaling the fumes damages workers' lungs and increases their risk for cancer and other illnesses.
We are suffering for a year because the heat is there, where the smoke to the disturb us.
Other studies have found that large e-waste dumps contaminate water, soil, and crops. Even if e-waste is properly recycled, the final product still needs to go to a smelter, the energy-intensive endpoint for most mining operations. Mint's long-term goal is to make it easy and profitable for cities to process their e-waste locally.
We need to kind of get this, really cranking throughout the world, and that's probably a 20-year vision.
The company is planning full-scale facilities in Australia and the United Kingdom. This smaller plant in Auckland, New Zealand, was built to demonstrate how Mint's process works. It processes about 1 metric ton of circuit boards per week, but larger plants, like the one they're building in Australia, will process 10 metric tons per day. That would make the bigger plant able to process about 1% of all the e-waste Australia produces annually. The planned larger facilities will be almost entirely automated.
It's pretty light touch from a personnel perspective. Might have 3 people on the shop floor at any one time, running 24/7.
The small number of employees would have limited contact with e-waste, keeping them safe from exposure to toxic compounds. However, even if Mint can realize its dream of a plant in every major city, the founders face another problem that's completely out of their control.
And unfortunately, electronic waste generally is getting less and less valuable over time as a commodity.
Manufacturers are learning to build gadgets with less precious metal. Mint's team is researching other types of waste they can run through this process, like car parts. As for solving the global e-waste problem, Jim Puckett remains skeptical that any form of recycling is the answer.
I'm not saying don't go ahead with these techniques. We're certainly going to have old circuit boards around for a long time, and we're going to have to deal with them. So let's move on it. But we got to turn off the tap.
That tap is controlled by the companies who manufacture electronics, most of whom have no legal or financial incentive to design products that can be recycled.
It's an overflowing bathtub. You can't run around with mops and say, oh my God, we got to mop this up, we got to mop that up, and we have a better mop here and a better mop there. When the tap is pouring water into the bathtub, it's overflowing down the stairs. This is the problem we have, is the tap of our waste is not being turned back.